While NASA's space websites flicker offline and Earth's telescopes are blinded by the sun, a third confirmed interstellar object, 3IATLAS, races past Mars at 30 million kilometers. It's the ultimate cosmic irony. Just as this bizarre emerald-glowing traveler draws closest, America's own science feeds go dark. Only Mars-orbiting spacecraft from Europe, China, and the UAE can seize the moment and reveal what Earth cannot see, capturing the sharpest images and data before 3IATLAS vanishes forever. But as the world's best instruments pivot under pressure, what will Mars side eyes uncover about an object that defies every comet rulebook? The clock on this alien encounter is already ticking. On October 3, 2025, the solar system's geometry locks Earth out of the action. As 3IATLAS sweeps past Mars at just 0.2 astronomical units, about 30 million kilometers, the Sun stands directly between us and the comet. From Earth's perspective, the elongation angle, the slice of sky separating the Sun from 3IATLAS, shrinks to under 10 degrees. For ground-based telescopes, this is a hard stop. Most observatories refuse to risk their optics or sensors when a target dips below 15 degrees from the Sun. By early October, the comet's position falls well inside that danger zone, not just for a night or two, but for nearly 6 weeks, stretching from late September through early November. Mars, however, sits offset in its orbit by more than 40 degrees. The Sun 3IATLAS Mars angle on October 3 is broad, often greater than 50 degrees. That means Mars orbiters and surface assets have a clear, unobstructed view, while every eye on Earth is blinded by solar glare. The numbers tell the story. At the moment of closest approach, Earth's view is blocked, but Mars has a front-row seat. Any change, any outburst, any anomaly in 3IATLAS's behavior during this window will be seen first or only by the machines circling or crawling on the red planet. For this brief slice of time, Mars becomes the solar system's only watchtower. Every hour lost now is a permanent gap in the record. The window for Mars-side observation isn't measured in weeks or even days. It's a handful of orbits, a sliver of time before the comet speeds away and the geometry changes again. Mission planners, usually working months ahead, have to improvise. Standard protocols are set aside for emergency retargeting. Instruments designed to scan Martian valleys or sample the thin air are suddenly aimed into deep space data. Pipelines calibrated for routine science are forced to handle bursts of raw telemetry and quick-look images, hoping to catch any outburst or anomaly before it fades. The pressure is relentless. Each pass overhead, each downlink opportunity might be the last chance to capture a new feature or a sudden flare. There's no time for bureaucracy or second guesses. Everything depends on the speed and flexibility of the teams behind those distant machines. Mars orbits under the watch of multiple spacecraft, each designed for a different slice of the electromagnetic spectrum, each answering to its own mission team. ESA's Mars Express and the ExoMars Trace Gas Orbiter have secured high-cadence observation slots for the week of October 3rd. Mars Express employs its high-resolution stereo camera and omega spectrometer to capture multispectral images and analyze chemical signatures from visible to infrared. Trace Gas Orbiter's NOMAD and ACS spectrometers dissect the comet's light into thousands of wavelengths, searching for rare gases and molecular bands. Both can pivot away from Mars to track the comet, but every maneuver is balanced against thermal and safety constraints. The UAE's HOPE orbiter brings a different perspective. Its XE camera and EMUS ultraviolet spectrometer, normally focused on atmospheric science, can be retargeted to monitor bright objects in the Martian sky. HOPE's global orbit and flexible pointing make it ideal for wide-field imaging and ultraviolet spectra. Especially during rapid response campaigns, China's Tianwen-1, equipped with high and medium-resolution cameras and a mineralogical spectrometer, could provide context images and near-infrared spectra if retargeted. Though official confirmation is pending, data from Tianwen-1 typically enters the public domain through curated releases or scientific papers. NASA's Mars Reconnaissance Orbiter, with Horizon Chrism, has a track record of comet and asteroid campaigns. Targeting depends on pre-approved plans and spacecraft safety, and the current U.S. government shutdown complicates public access to new data, even if MRO collects it. Internal teams continue monitoring for spacecraft health and planetary protection. Beyond Mars, ESA's JUICE spacecraft will attempt to observe 3IATLAS during its outbound cruise in early November. The geometry is less favorable, and its instruments, Janus, Magis, and UVS, are built for distant, faint targets. Any data JUICE gathers will face a long downlink queue, with public release not expected until early 2026. Even a few spectra or images could help track the comet's activity as it rounds the Sun. This network forms a layered approach, each mission contributing a unique field of view and spectral range. Some results will arrive within days, others only after months of validation. Staggered releases and cross-agency coordination ensure the story of 3IATLAS will unfold in stages. Each dataset a potential clue. 9 minutes. That's the length of the Perseverance rover's unbroken gaze at the Martian sky on October 2nd. Each frame snapped by Mastcam Z is stamped with a precise UTC timestamp, exposure time, filter, and camera orientation. The sequence was designed for sky surveys, but this time a streak appears. It cuts across the star trails, neither aligned with known satellites nor matching the slow drift of planets. Calibration begins. Raw images are flat-fielded, dark subtracted, corrected for bad pixels. Every artifact, cosmic ray, and ghost reflection must be hunted down. Only then does the streak stand out, a faint, fast-moving line consistent in each exposure. Astrometry takes over. Analysts pull spice kernels, NASA's geometric toolkit, to translate the rover's pointing into sky coordinates. The predicted path of 3IATLAS, derived from JPL Horizon's ephemerades, is overlaid. The streak's angle and speed, nearly 400 arcseconds, match the comet's projected motion from Jezero crater at that hour. False positives must be eliminated. Cosmic rays leave single-pixel scars, not long continuous tracks. Internal reflections and ghosting repeat with camera movement, but this streak holds steady. Median filters and sigma clipping weed out transients. Photometry confirms the brightness aligns with a diffuse, fast-moving coma at Mars's distance. The final test, fit. The streak's position plotted against the predicted ephemeris shows residuals within a few arcseconds, well inside the margin for error. Evidence mounts, but official confirmation remains out of reach. The US government shutdown leaves JPL's instrument leads silent. Independent analysts have published findings, but verification waits for NASA's endorsement. If real, this would be the first direct detection of an interstellar object from the surface of another planet. Science demands rigor. Calibration, astrometry, photometry, false positive screening must withstand scrutiny. The streak is there, burned into 9 minutes of Martian sky. Whether it becomes a landmark detection or a cautionary tale depends on what comes next. On September 25th, a single amateur observatory in Namibia delivered what would become the last clear portrait of 3IATLAS before Earth's window closed. The image, taken hours before the comet slipped into solar conjunction, captured an emerald coma stretching nearly 700,000 km, nearly twice the distance from Earth to the Moon. The core glowed green, a hue set apart from most solar system comets. Sunlight filtering through diatomic carbon and other gases produced a vivid, almost unnatural color. But the structure was stranger still. Instead of a long trailing dust tail, 3IATLAS displayed a sunward antitail, a wedge of material pointing toward the Sun, not away. Fainter shells and arcs rippled outward from the nucleus, suggesting episodic ejection rather than a steady wind-blown stream. Follow-up image stacks from September 27th and October 2nd, though noisier, confirmed the pattern. The coma's boundaries held their shape, resisting smearing and elongation expected from a typical dust-driven tail. Each new frame reinforced that this was not a standard comet, but a visitor with its own internal logic. The numbers don't lie. Velocity. Most long-period comets limp in at 20-30 km/s. 3IATLAS roars past Mars at nearly 60 km/s, spiking to 68 km/s at perihelion. Its trajectory hugs the ecliptic, with inclination just a few degrees off the plane of the planets, statistically rare for an interstellar visitor. Size. Early brightness estimates suggest a nucleus at least 5 kilometers across, among the largest interstellar bodies ever observed. The coma confounds further. Instead of a classic dust tail, a sprawling layered envelope dominates. Polarization studies hint at concentric shells or arcs. No long filamentous tail, just a massive structured cloud that defies standard comet physics. Despite solar heating and a coronal mass ejection, CME, on September 25th, the green halo barely budged. Morphological change was minimal, no obvious ion tail, no abrupt brightening, not even a ripple in the layered arcs. Researchers now look to Mars orbiter plasma instruments and high-cadence spectra for clues, hoping that somewhere in the raw telemetry, the fingerprints of that solar storm are hidden, waiting to be found. The orbit of 3IATLAS confirms its interstellar origin, unbound, never to return, alongside only two previous visitors, 1D Oumuamua and 2I Borisov. But the real challenge is understanding its nature. Some scientists call it an interstellar comet. Others hesitate, citing its missing dust-tail, anti-tail, stubbornly stable structure, and almost mechanical velocity. Science advances through skepticism, not hype. Until new data arrives, the only certainty is its interstellar passport. Everything else remains a hypothesis. For those following the story, the most important tools are public data streams and community-driven analysis. Check ESA's Planetary Science Archive, the UAE HOPE mission's data site, and ExoMars Trace Gas Orbiter releases. Independent analyst forums track raw uploads, flagging anomalies as they appear. Verification happens in layers, cross-referencing observations from Mars orbiters, amateur networks, and solar observatories. On October 3, 2025, 3IATLAS passed just 30 million km from Mars, while Earth-based observatories were blinded by solar conjunction and a US government shutdown. Mars orbiters became the sole witnesses, capturing data unavailable from Earth. Early images confirmed a green coma over 700,000 km wide and a speed near 60 km/s. Yet key questions persist. The comet's true composition, the reason for its layered coma, and the absence of a classic dust tail. Even after a close encounter with a solar CME, expected ionization effects were minimal. As international teams process their findings and prepare for staggered data releases, much remains unexplained. The confirmed interstellar origin of 3IATLAS is undeniable, but its nature challenges current comet models. Until new data arrives, the story of this visitor is unfinished, reminding us that even with global assets, some cosmic mysteries endure. Okay, listen up. This isn't just any space story. This is the story of an interstellar visitor, like nothing we've ever seen, a comet that doesn't follow the rules. Green, glowing, moving faster than anything in our solar system, with a tail that points toward the sun instead of away from it. And here's the crazy part. While everyone on Earth was blind, Mars became the front-row seat to history. Europe, China, the UAE, they all scrambled, pivoting cameras and sensors designed for Mars itself, just to make sure we didn't miss a second. Every orbit, every downlink, could have been the last chance to catch something insane. Now imagine this. 9 minutes of perseverance staring at the Martian sky, catching a streak nobody on Earth could see. Every pixel had to be checked, every false positive ruled out. And what did we find? A comet that laughs at everything we know about physics, a green halo, a structured layered coma, a speed that makes our fastest comets look like snails. This is the kind of discovery that makes you stop and say, what the heck is out there? Because 3IATLAS isn't just a comet, it's a cosmic puzzle, a challenge to everything we thought we knew. And the truth is, we're only seeing the beginning. More images, more spectra, more surprises are coming, and Mars is leading the show. So here's what I want you to do. If you want to stay on the edge of your seat as we watch the universe unfold, hit that subscribe button right now. We're tracking this interstellar mystery every step of the way, and you don't want to miss what comes next. And hey, share this video with your friends because the universe doesn't wait for anyone. Who knows? The next comet, the next streak across the sky, might be even stranger than this one. And when it happens, we'll all be watching from Mars's front row. Atlas has shown us something incredible. The universe is alive with mysteries, and we're just starting to catch a glimpse. So buckle up, because this story is far from over, and trust me, you want to be here when the next chapter drops. Mars has the front row, and we're lucky enough to watch. Make sure you don't blink. Hit that like button, smash subscribe, and join the mission, because space is just getting started.